All right, so today is the 29th, it's Tuesday, and now that we've learned how to find the area of parallelograms and trapezoids, and you already know triangles and circles and rectangles, we can kind of change up the information we give you. We can give you the area of these things and ask you to solve for an unknown dimension like the height or the base or the radius. And it's really cool because we use our algebra equation solving skills to do this. So it's a great lesson that comes back to the algebra. We have here our first example. To find the height of a parallelogram with a base length of 9 centimeters and an area of 30.6 square centimeters. Now this is an easy one, you know, I tend to start with easy ones, otherwise it gets overwhelming. But whether it's an easy or difficult one, there's 3 basic steps I want you to follow. And the first step is to write the applicable formula. So, having read this problem, problem A, what is the applicable formula that goes with it? Please? What's the formula for it? What shape is it and what formula goes with it?
It's a parallelogram.
Good. Area equals base times height. Now, I know this is an easier one. Some of you can do this one. But every time I want you to write the formula, because for the more complicated ones, it will guide you. The second thing you do after you write the formula is you substitute in the values you know. So in this particular problem, do we know the area? Kelly?
30.6.
Good. So I substitute that in for the area. Do we know the base or the height? Alan? Where are you getting that from?
Oh, sorry, that's B.
Okay. We know the base is what? 9 centimeters. So we substitute a 9 for B, and we don't know the height, H. So we just leave the variable there. Now, what do you do to solve this for H? What do you do, Jack?
You divide 30.6 by 9.
Right, we actually show dividing both sides of the equation, right? And we'll get H equals. No calculators today because you guys need to practice your division and division with decimals especially. You got a whole number out here. You just put the decimal up here and divide carefully, but watch your placement. 9 doesn't go into 3, so you move over. 9 goes into 30 3 times. Bring down the next digit. 9 goes into 36 4 times. So the height is 3.4 centimeters. Really basic one to start out with. Are you good on that?
Mm-hmm.
All right. Step 3, I forgot to write it down, was to solve for the unknown. You got the 3 steps written there?
Mm-hmm.
Because the beautiful thing is we're going to follow those 3 steps for all of these. Moving on. Letter B, we just have a picture. But we follow the same steps. So, what is the applicable formula for this shape? What shape is it and what formula do we got here? How about, yes?
So it's a parallelogram.
Does it have 2 pairs of parallel sides?
No, it's a trapezoid.
Very good, it's a trapezoid. So what's the formula that applies to trapezoid, Connor?
Base 1 plus base 2.
And you're missing a little.
1.
Good. 1/2 the sum of base 1 plus base 2 times the height. So that's step 1, writing the applicable formula. Step 2 is substituting in what you know. So start to help me figure out what I can substitute in. What's something I can sub in here? Component.
Base 1, base 2. Base 1's X, and base 2 is 10.
Okay. What's something else I can sub in, Julian?
The area is 72 centimeters squared.
Good. And what about H? We don't have anything going on for our formula for H. Jack?
The height is 6.
The height is 6. Okay, so I substituted everything in, and now I can solve for the unknown, which is buried here in the middle of my equation. Let's just talk about a little bit of manipulating that we can do here. First of all, a lot of you like to flip-flop the formula to have the unknown on this side, and that's no problem. You can do that if you want. We have 3 things multiplied by each other here on the left side of the equation now. We can rearrange them because it's all multiplication, right? I would rearrange it like this. So that I have my 1/2 times 6 next to each other, because what's 1/2 of 6, Ethan?
3.
3. So this equation now is simplified to 3 times the sum of x plus 10 equals 72. That looks like an equation you solved in the past. What would you do to solve this? Mason?
First multiply and then solve like we did with the variables.
Okay, so what do you want me to multiply here?
With 3, so it's 3x plus 30.
Good. And then you solve, Mason said, like we've been doing. So what would 3x be equal to, Julian?
It would equal 42.
Good. And what would x equal, Lise? 14, good. Now, I want you to all, any questions about that first? So you can see how we're using our algebra here. And this is centimeters, don't forget to label it for units. I want to show you though, do you have a question?
I did, but I see it.
Okay. I want us to come back, I want you all to look at this step right here. Because there is a different way you could solve it from this step, and I want you to be aware of it, because sometimes it's easier. So I'm going to just rewrite this line of my equation solving over here. And you don't have to do what's going to follow, but sometimes it's really nice and convenient in a faster way to solve. I have 3 times the sum equals 72. You can solve for just what the sum is next. So if I know 3 times the sum is 72, what could I do to get just the sum by itself, not 3 times it? Yeah, Jack?
Could you divide by 3?
Yeah, you can divide by 3, and then you'll get what just the sum, x plus 10, is. Which 72 divided by 3.
I did it before.
You did it this way before?
No,
You were doing
I
something
did
else.
72 divided by 3. Good.
And then what do I do to finish and solve for x here? What do I do, Kelly?
You can do divided by, or multiply by x equals 14.
14. You see we got the same thing both ways. Sometimes this way is easier to, if you have a coefficient times a sum, sometimes it's easier to divide by the coefficient first. I'm not showing this to confuse you, I'm showing this to give you options in case it makes your life easier. If you're somebody who's not ready for options, then you can just always continue like we solved it the first time through. But some of you might really like doing it this way too. Any questions? All right, next problem. Oh, this is fun. Capital F.
Calculate. You have calculator?
Oh no.
Oh.
All right, why don't you read it for me, Capone?
Area of the circle is 78.5 centimeters. Calculate the radius of the circle. Times 3.2.
4 pi. Okay? All right. So, what's the applicable formula for this problem? Rhea?
Okay, so area equals pi r squared.
Very good. Okay, so you're doing a good job with all those different formulas. Yeah, this is about the area of a circle. So the formula we're going to use is a equals pi r squared. That's step 1, write down the applicable formula. Step 2 is what, Alex? Good. So let's sub in what we know. What's something we know, Mason?
The area,
Is
78.5 centimeters squared.
good. What else is something we know? What do we know? I haven't called on Margaret. Pi is 3.14. r squared, we're trying to find r, so we can't substitute anything in for that. What do we do now, do you think? What think you? Naja?
And subtract it from 5 and
Subtract it?
Wait,
This is 3.14 times r squared. How do we separate the coefficient from the variable term? Divide it. Yes, we must divide it. And when we do, the 3.14s will cancel and we'll be left with r squared. I must digress and talk about decimal division. Again, this is a major weakness, and it is now my mission to exterminate the weakness. What do you remember about this, Ethan?
You can change it to a whole, but you have to do it on both numbers. So you can multiply the 3.14 by 100,
Good.
and
Which
then
means,
you have to multiply that by 100 too.
good. So that means then, my decimal point now is there, and it stays there. This is what kids are. Kids just like kind of go blah and forget about it, just divide, but don't keep track of their place values. You have to. So 314 does not go into 7. It might help you to put a little X there. It does not go into 78. It does go into 785. How many times? Approximately. Jack? 2. So, and 2 times 314 is 628. I subtract. And I bring down the 0, and I ask myself, does 314 go into 1,570? Please? Yep. How many do you guess?
5 exactly.
cheated.
And sometimes it's a good idea to just look at the far sides of the numbers. 3 into 15 goes 5 times, so that would be why I would guess 5. You could have guessed 3 or 4 over here and done them, and you would have corrected yourself. But you're right, yes, it goes in there exactly. Yes,
This is why it says calculus.
yes.
So we can do that.
No, you can't use your calculator. You gotta practice these. It's a weakness. That's like, buddy, if you couldn't shoot a shot on goal with your left hand, do they call it your left stick? I don't know what they call it. You wouldn't avoid practicing that, right? No, you shouldn't. Not if you want to be a star hockey player. You don't shoot either way? All right, then if you're playing,
Like, there's a bat.
You're really reaching, Mrs.
so that's what I mean, a backhand. So it's like tennis, there's a backhand. Okay, so if you know your backhand's weak, that's what you're gonna want to practice. Or well, you might not want to, but you know if you want to be great, you should. All right. We have digressed and we have to move on. So r squared equals 25. What do we do to get r? Oh, what do we do for that? Alec?
We divide this
Good. Which is 5. So my radius equals 5 centimeters. Okay, so we've looked carefully at this parallelogram, and the difference between this problem and the ones before it is that we aren't given the area. So we have to find the area of this in order to solve for our unknown height x. The way to do it, the key to it, is to look at it this way and realize that you can use this side of the parallelogram as the base with this height, because then we can find the area of the parallelogram. How do you get the area of a parallelogram, Julian?
Base times height.
And what is the base and the height when we look at a parallelogram from this perspective? Lena? 6 times 8. So the area of this parallelogram is what, Lena? 48 square centimeters. Okay, that's cool. Now hold on, I want to put it back. Okay, so we reoriented, and now this time we can say, all right, I'm going to use this side as the base, and this is my height, and I know my area hasn't changed. So I use the same formula, base times height. I know the area is 48. The base this time is 9.
5 seconds.
The height is x. Now you can solve, and when you do, you get x equals 5.